Hi everyone, it's Math with AUB. We have continued a series of how to find domain of a function. Let me remind you one time more. We have to take care of three things in order to find the domain of a function. Number one, denominator never ceases to exist. We have to discard all the values where denominator is overall 0, where denominator is completely 0. We have to omit all these values of independent variable. Number two, log are defined for positive values, and mostly we are dealing with real valued function unless we have been told. In that case, in square root we cannot afford overall negative result. If overall result is negative, it is iota times something, and it is a violation for a real valued function. It is a violation. We cannot afford them. Domain some sort of real numbers or subset of real numbers, as well as their range is also real numbers, because we are dealing with a real valued function. Number one, denominator never ever be 0. Discard all the values where denominator ceases to exist. Number two, log is defined for positive values. In square root we cannot afford overall negative result, because we are dealing with the real valued function unless clearly explicitly mentioned to you that it is a complex value function. Question number 4, it reads as the domain of the function f of x is equal to x minus root 1 minus x square overall root. Here comes the square root. In square root we afford some positive values are 0, because the overall square root lies in numerator. So overall this result is equal to 0. We can afford it is a defined quantity. So in that case we take the inequality x minus 1 minus x square is greater than or equal to 0. We can also afford 0 because function completely lies in numerator. If numerator is completely 0, we can afford it. Okay, solving for x, shift this quantity here, it will become x is greater than 1 minus x square. Squaring both sides, we have x square inequality remains as it is, greater than or equal to 0, greater than or equal to 1 minus x square. We have got rid of square root. It will become 1 minus x square. Collect the like terms. X square plus x square is greater than or equal to 1. So it gives us 2x square is greater than or equal to 1. So x square is greater than or equal to 1 over 2. It is not like x square less than or equal to 1 upon 2. It is x square greater than or equal to 1 over 2. For this we have to discard these values from minus 1 over under root 2 to 1 over under root 2. We have to discard these values. Not to be taken. Discard this interval. Or one can write this one as x is less than or equal to minus 1 over under root 2, or x is greater than or equal to 1 over under root 2. Either you write in that form. We have to discard this. Open interval, and in that case x is less than minus 1 over 2. It is x is greater than or equal to 1 upon 2. Let's see its representation on a real line on x-axis. Okay, that's r0. That is somewhere minus 1 over square root 2. That is greater than positive 1 over under root 2. It means x is less than this one, means we have to travel towards left hand side. This 1 over 2 is inclusive. It is inclusive because less than or equal to. Okay, this might be our domain. What about this? This is also 1 over 2 inclusive, including this. If it is greater than, then we have to travel in the rightward direction. Look, we have discarded this open interval minus 1 over square root 2 to positive 1 over square root 2. This one, we have discarded that symbol. If you take any value from this, take a 0 from this, it is 0, it is also 0. Overall minus 1 in square root, it is under root 1. it is complex quantity. We have to got rid of this thing. Either this is our domain or this is. We have reconciled overall fact. What about we have another square root? We have another square root. Let's settle this down. It is our 1 minus x square. It must be greater than or equal to 0. I am only taking this. 1 minus x square greater than or equal to 0. It will give me 1 is greater than x square, or x square is less than 1. It is our normal interval. Minus 1 is less than x, x is less than 1. Okay, for this we have to take, this is our interval. For this it is minus 1 including, and that is our positive 1. That is. Now we have to find their intersection. We have already discarded that portion because it gives us negative values in the square root, that is complex having iota, so we have to discard this one. It is overall negative. We cannot afford this one as well in square root. If you want to plug anything from in between, you will get something negative. Only portion remains this one, that is our domain in that case. 1 over square root 2 to positive 1. That is our domain of the function that gives us a real valued function for this overall function, x minus under root 1 minus x square. X minus under root 1 minus x square. What I have done, I have taken collectively whatever is present in overall square root. I have taken this, I have solved for greater than or equal to 1. Here is the game. It means that we have to discard this open interval from minus 1 over 2 to positive 1 over 2, or x is less than minus 1 over 2, or x is greater than or equal to 1 over 2. Take care of this thing. X square is greater than or equal to 1 over 2. Greater than or equal to 1 over 2. We have to discard that one. And there is another square root inside another square root, taking this 1 minus x square according to definition greater than or equal to 0. It is normal one. X square is less than or equal to 1. It gives us a closed interval from minus 1 to 1. Pointing or mentioning all these points here, we have already excluded this one because it gives negative values in the square root. This is also a negative portion. We cannot afford negative values of x, and they also gives negative values of this overall function. One can plug in any value. What remains here? This is the tiny portion of our domain that I have written 1 over under root 2 to positive 1, including 1 over square root 2 and 1 over under root 2 to 1. That is our domain in that case. In that case, our option number D is the right option. Moving towards next question, we have